All right. So, what is concavity? Yeah. So you can have concave up or you can have concave down. So basically, where the function opens up towards is concave up or concave down. Okay. Now, if a function is concave up, like this parabola, all right, then f prime, since this is decreasing, okay, 0 and increasing, f prime is changing from negative to positive. If f is concave up, right, then f prime is, again, changing, yeah, from decreasing to increasing, or negative to positive. If it's concave down, then f prime is changing from positive to negative. Now, that is not generally going to be the way we determine something is concave up or concave down. That just happens to be what's going on. Okay. It does tell you that, again, if a function is concave down, then you're going to have a local minimum. If the function is concave up, you will have a local maximum because, again, where we have a local minimum, it changes from positive to negative or negative positive. Yeah. There's concave up, we have a local minimum. Concave down, we have a local max. There we go. Yes.
Since the local minimum or maximum, does it automatically make it a concave up or concave down?
If you do know where you have a local min or local max, yeah, then you will have a concave up or concave down. That will be a part of it. Now, what we are primarily going to be using is what's called the second derivative test. Okay, not really second derivative test, but we're going to take the second derivative because where the second derivative is greater than 0 or positive, that means f is concave up. Where the second derivative is negative, that means f is concave down. Ow. If we look at here, from here to here, all right, f double prime is, what are you doing? Why are you doing that? Hi. Glad that's, why are you doing that? There you go. Glad that's recorded. All right. So f double prime is less than 0 here because it's concave down. Okay, so from here to here, f double prime is greater than 0. And then here, f double prime is less than 0, and so on and so forth. F double prime is greater than 0. No, sorry, less than 0. I had that backwards. Sorry. My bad. That is backwards. Concave up is greater than 0. Concave down is less than 0. Now, These points right here, where it changes from concave up to concave down, all right, these are what's called points of inflection. They're at the bottom of your page there. Points of inflection. I just figured we'd go ahead and bring them up. So, points of inflection where it changes from concave up to concave down. So what we're going to do is we're going to do something similar to finding where a function is increasing and decreasing, which is we're going to be finding where the second derivative is positive or negative. Now, in order to do that, we need to first find the first derivative. So what is f prime of x? So that should give you what? X cubed minus 12x plus 1. Then the second derivative. Sorry, I got something in my throat, so it's tickling. That's better. All right. So the second derivative will be what? 3x squared minus 12? Well, it's pretty easy to find the zeros for that. Factor out 3. X squared minus 4 gives you x equals plus or minus 2. Try that again. So we have x. We're going to have f double prime of x. There's something very similar. We have negative 2, positive 2, and then everything in between. So again, we're going to treat this very similar to finding local max, local mins, and for functions increasing and decreasing. We're just going to plug this into the second derivative. Now, if I plug in, let's say, negative 3, negative 3 squared is positive 9. 3 times positive 9 is 27. 27 minus 12 gives you a positive 15. So that's positive. We know that 0, that's 0. If I plug in 0, well, 0 minus 12 is negative 12. And if we plug in positive 3, we're also going to get the same thing, positive 15. So, our function is concave up, right, from negative infinity to negative 2, right, and 2 to infinity, because f double prime is greater than 0. Concave down from negative 2 to 2, because f double prime is less than 0.
So when you're doing a concave, you do the double derivative. So then when you're just doing like
local max, local mins are increasing and decreasing. Yeah, I do see the derivative. Yep. Real fun stuff is when we have to do both. I don't know. Let me see. Lesson 9, 5-9. So after break. Yeah. Good. All right. So we mentioned that these right here, these values at 2 and negative 2, okay, these are called points of inflection. Okay, I don't really want to write all of it out. But again, a point of inflection is where the graph changes concavity. Okay, where it changes from concave up to concave down. Good. All right. Any questions on that so far? Easy enough? Okay. So, 2 common mistakes when finding point inflection. Assuming that f double prime equals 0 means there's a point inflection. That's not always the case. Okay. It could very well be that the double prime equals 0. It could still be a critical point. It could be a local max or local min. Okay. Sometimes it happens. Right. Sometimes that will happen. Right. And assuming that f double prime doesn't equal 0 means there is no point of inflection. Okay. More or less the concept of where it's concave up and concave down. Sorry, where it's does not exist. All right. One thing that's going to help is if we are given the derivative of the function. Okay. If we're given the derivative of the function, so number 2, we are given the derivative. All right. Where would the second derivative be negative? Where is f double prime of x less than 0? How would you find out where the second derivative is less than 0 when you're given the first derivative? Let's put this in context, something you should already know. Oh, somebody's already got it. All right. If you have the first derivative, how can we tell if you have the original function, how can we tell where the derivative is negative? When the slope is negative. So if we have the first derivative, how can we tell where the second derivative is negative? When the slope is negative. So we are looking at when f prime of x is decreasing. So if we have the graph of the first derivative, we can say it's concave down wherever f prime of x has a decreasing slope, has a negative slope. So where do we have a negative slope? Yep. So I'm just going to use CD for concave down and CU for concave up because I don't feel like writing it all out. So concave down from -4 to -1, and where else? 1 to 2. All right. Concave up, where it's positive, that will be from -1 to 1, and 2 to 3. Now it does say find the points of inflection too. So where's the change concavity? Here, here, and here. So points of inflection would be x equals -1, 1, and 2. Now, where it's even easier, because we already said this, if we have the second derivative, where is it concave up? When the second derivative is what? Positive. It's concave down when the second derivative is negative. So everywhere up here, concave up, concave down. So where is it concave up or concave down? We'll do concave down first in order. Concave down from -1 to 1, right? So -1 to 1. 1. And from 3 to infinity, because these have arrows on them.
Isn't it -3? Where do you get
Oh, it's -3. You're right. I can't read my own graph. There you go. Yeah.
No.
So -3 to 1, and then 3 to infinity. All right. Concave up from where? Infinity up to -3, and from 1 to 3. So points of inflection. Now the points of inflection would be where it crosses the x-axis at -3, 1, and 3. Thing is, it must cross. If it doesn't cross the x-axis, okay, so like right here, if this was f double prime, this would not be a point of inflection because it does not cross the x-axis. Okay, so it must cross the x-axis. Just like again for local max and local mins, when you're taking the first derivative, it must cross the x-axis. Otherwise, it's not a local max, local min. Does the tangent line of the graph of this function at x lie above or below the graph of f? So remember when we talked about when we know a function is our tangent line is above or below the graph? It's above the graph if it's concave down, below the graph it's concave up. So now not only are you going to need to know, well, eventually you don't actually have to find the equation of the tangent line here. You just need to know is the function concave up or concave down at that point. Okay, now to do that, what do I need to find? The second derivative. And I plug in 1 to see if the second derivative is positive or negative. If it is positive, it's concave up, which means the tangent line is below the graph. If it's negative, it's concave down. What? You didn't need a calculator for this. It would not be helpful. So, f prime of x, it just means you're going to do product rule. What's the derivative of x? 1, so 1 e to the negative x. What's the derivative of e to the negative x? Negative 1 e to the negative x. So technically we get minus x e to the negative x. So that's your first derivative. All right, second derivative. Now, the nice thing about this is that just becomes negative 1 e to the negative x. This becomes negative 1 e to the negative x plus x e to the negative x. Now, if you notice here, you can factor out an e to the negative x here.
The double.
Yeah, sorry, second derivative. My bad. Chain rule. Yeah, you have to do the derivative of the exponent as well, which is -1. So you can combine this a bit, okay? Or honestly, you can just plug in what? 1, right? If you plug in 1, you get what? E to the -1 minus e to the -1 plus e to the -1.
What?
So which one? Oh, yeah, sorry, negative. It was negative. What? So if you plug in 1 here, that's what you get, right? What is that going to equal? Negative e to the -1 or -1 over e? Because these two do what? Cancel out. One's positive, one's negative, same thing. Now is that positive or negative? So f double prime of x is less than 0 at x equals 1. Therefore, the tangent line would lie above the graph of the function. Because it's concave down.
We're not doing.
Let's do the next section.
Oh,
I need the test too. Why not? We got time.
I'm busy on the.
Besides, you're either going to complain today or complain tomorrow. I might as well get it over with. Or do both days, because that's kind of how you guys roll.
You walk in and say,
We did double Monday, huh?
Yeah, you did.
well, besides that.
Besides that day.
All
All right. So, 5.7, second derivative test. Before we get started, I want to make this note. The second derivative
Will be just a homework.
test fails when f double prime of c is equal to 0. Okay, so when you're doing the second derivative test, right? Right. If you get f double prime is equal to 0, then you cannot do the second derivative test. You have to do what's called the first derivative test. If you remember, the first derivative test is about finding what? Your local max and local mins. Okay. We can do the second derivative test to also find your local max or local min, because like we said, right here, this is concave down, right? If you're concave down, your critical point will be a what? Local max. Okay, so it's local max when it's concave down. Okay, right here, it's concave up. So concave up, which means this will be a local min. So you can find your critical points and then plug them into the second derivative to see if it's positive or negative. That's it. If you find your critical points and you plug it into the second derivative and get positive, that means it's concave up, making it a local min. If you get negative, it means it's concave down, you have your local max. The problem is, if it's not positive or negative, then what do? We have to do the first derivative test. If you get 0 when you plug in your value, you have to do the first derivative test. You cannot do the second derivative test. Okay. All right.
First derivative constant can't be turned into
At
a
least 5.7.
hypothetical.
No, if you plug in c and get 0, not that the first derivative is constant, not that the whole derivative is constant. It's just, yeah, it's not f prime of x equals 0, it's f prime of c. So, all right. So, we kind of mentioned this. What do we know about the value of f prime of c at f prime of x equals 0? We know that f prime of x is equal to 0, or f prime of x does not exist. Those are the two rules. Okay. What do you know about the value of f double prime at each extreme? Well, again, in that case, we just kind of talked about it where it's concave up and concave down. So, the rule we just stated, okay, the rule we just stated, does state, suppose that f prime of c is equal to 0. Suppose we find your critical points. Notice what's not there from part B.
What?
This does not work for f prime of x does not exist. It only works when you have zeros, which again will be majority of the time. When you're given actual functions where the function does not exist, does only really happen with rational functions. Okay, you're not going to see a lot of those. Okay, you're going to see your nice quadratic or polynomial functions, some exponential functions. You're not going to see a lot of rational functions. So here's what we're going to do. We are going to take the first derivative. What is f prime of x?
4x.
4x cubed minus 4x, which we can factor out of 4x. And that gives you x squared minus 1, which is x plus 1 and x minus 1, right? So what are my critical points? 0, -1, +1, right? Any questions about that? All right. So what we're going to do now is I'm going to find the second derivative. What's the second derivative? Okay. With this, we are going to find what is f double prime of -1, f double prime of 0, and f double prime of +1. Now, being that we're squaring the values, I should get the same answer for -1 and +1, right? So if I plug in 1, what do I get? 8. And -1, you get 8. If I plug in 0, I get -4. That means this is concave up at -1 and concave up at +1. It is concave down at 0. So, relative max at x equals 0, because f prime of x equals, well, f prime is 0, sorry. F prime of 0 is equal to 0, and f double prime of 0 is less than 0. Relative min at x equals plus or minus 1, because f prime of plus or minus 1 is equal to 0, and f double prime of plus or minus 1 is greater than 0. The big thing, big plus about doing this is you don't have to make the chart. You can find the critical points, do the second derivative, and just plug in values. If you get positive, it's concave up. Concave up means you have a minimum. Again, if you need the visual, concave up. Okay? Concave up. All right? So again, concave up or concave down. Do you need the visual to see, well, this must be a local minimum where it's concave up, local max where it's concave down. All right, any questions on that? Yeah, we don't do absolute. The only time we do absolute, which is a very good point, the only time we do absolute, we have to find the values. Okay? So we have to find the values for absolute max. So you still find your critical points, but when is the only case we actually do find absolute max and mins? It's when we're given an interval. We have to have an interval because, again, most polynomial functions don't have absolute max and mins unless it's an even function. Okay? In those cases, it would either only have one, either an absolute max or an absolute min. Okay? But if we're given an interval, we can find the absolute max or absolute min over an interval. Okay? Which we test the critical points and we test the endpoints. But you do have to plug them in. You wouldn't really probably do the second derivative test here. You would just find the critical points, plug them into the function, and see what the values are if you're looking for specifically absolute max and absolute min. But this does bring up a good point here, because that very last thing is going to be talking about the absolute max and absolute min. Okay? But we'll get to it in just a second. All right, so we are going to use second derivative test on this. So again, first we need to find the first derivative. So what is f prime of x? What's the derivative square root of 2x? Square root of 2. Okay. What's the derivative of -2 cosine x? Plus 2 sine x. Okay. So where is this equal to 0? So basically, where does sine x equal, if you set this equal to 0, you're going to get negative root 2 over 2. So where is sine x equal to negative root 2 over 2 on the interval from 0 to 2 pi?
What?
If you set that equal to 0 and solve for sine x, what do you get? Yeah.
You're fine. Or
5.0.
It is over 4, because that root 2 over 2 is over 4. But if it's sine, where is sine negative? The third and fourth quadrant? Because third and fourth quadrant? So that would be what? 5 pi over 4 and 7 pi over 4?
Wow.
Because again, you all just are masters of the unit circle.
Fine.
We are going to take that second derivative. Now, the nice thing about that, what happens to the square root of 2? It goes away. What's the derivative of 2 sine x? 2 cosine x. So, what is f double prime of 5 pi over 4? Now, here's the thing. Does it really matter what the value is? No, it just matters if positive or negative. What is 5 pi over 4 is in what quadrant? The third. What's negative in the third quadrant? What's positive negative in the third quadrant? Everything's negative in the third quadrant, right? So this is going to be negative, which means this is concave what? Down. Okay? F double prime of 7 pi over 4 is the fourth quadrant, and cosine is what in the fourth quadrant? Positive in the fourth quadrant, so concave up. So we are going to have a relative what at 5 pi over 4? If it's concave down, it's a what? Max. Relative max at x equals 5 pi over 4, and that is because f prime of 5 pi over 4 equals 0, and f double prime of 5 pi over 4 is less than 0. Relative min at x equals 7 pi over 4, because f prime of 7 pi over 4 equals 0, and f double prime of 7 pi over 4 is greater than 0. Now, what happens if you only have one critical point? If you only have one critical point, that means there's only one turning point, right? And if there's only one turning point, that point must be an absolute max or min. So if there is only one critical point, the critical point max or min, then there is an absolute extrema. So it's not a local, it is absolute. So we're gonna do the same thing. And this is yeah, gonna be all kinds of fun. F prime of x. Oh, we only have a minute left. All right, we'll finish this tomorrow. Oh, we do have 4 minutes. We can get this done in 4 minutes. All right. That's right. We have nighttime. That's right. So first derivative, we have to do the product rule. What's the derivative of negative x? Negative 1 e to the x over 4. All right. Minus x. Okay, because we're gonna leave that. It would be plus, but what's plus and negative? Minus. What's the derivative of e to the x over 4? Times 1/4, right? So 1/4 e to the x over 4. Because the chain rule, right?
Perfect.
Now notice you do have that e to the x over 4, that negative e to the x over 4, right? So we can say f prime of x is equal to negative e to the x over 4. If we factor that out, we get 1 plus x over 4, right? If you factor out e to the x over negative e to the x 4, that's what we get. Now, is there any part of this that can be 0? No. But what can I plug in for x that would make this part 0? Negative 4. Let's try that with actual. All right. So that's my only critical point. Negative 4. Now, the real fun thing is I have to do the second derivative test because that's what we're doing today. So what is the second derivative of x?
Let's start with first. Let's kind of question.
We don't know that.
I'll let you know tomorrow.
don't know that. Like, this is right now.
So what it is negative 1/4 e to the x over 4 minus 1/4 e to the x over 4 plus 1/16 x e to the negative x to the negative 4. That should be no x. Sorry, not negative.
Whoa.
There we go.
I got that too. That.
There's a mistake. It should be negative. Should be negative. You can combine these two, right? Because they're the same, right? So we get f double prime of x equals negative 1/2 e to the x over 4 minus 1/16. Okay, x e to the x over 4.
Wow.
You can factor out a negative e x to the 4th, and we get 1/2 plus 1/16 x. So if I plug in negative 4 there, minus 1/4. Now 1/2 minus 1/4 is positive, right? So if this is positive and this is negative, what's the whole thing going to be? Negative, making this concave down. So we have an absolute max at x equals negative 4.
Start
What?
x over.
Because that's not going to change what e is. That no exponent is going to change the sign of e. Yeah. So that's why I didn't worry about it. Okay. I'll get you eventually.
You know, like that.
Yeah, I did.
You put up the solution.
Yeah, dude. Did I not post it?